Hello everyone. Let's start with something simple. Every day, we push, pull, lift, or feel resistance, from the weight of your school bag to the attraction of a magnet, from lightning in the sky to the gravity that keeps you on Earth. But did you know? All these countless forces in nature actually come down to just four fundamental forces. These are gravitational force, weak nuclear force, electromagnetic force, and strong nuclear force. Together, they govern everything from the tiniest particle interactions inside atoms to the motion of galaxies across the universe. Today, let's explore each of these forces, their properties, and their importance in shaping the natural world. Let's begin with the most familiar, gravitational force. This is the attractive force between any two masses in the universe. For example, the Earth pulls you down, and in return, you pull the Earth up with the same force, though the effect on Earth is negligible because of its huge mass. Gravitational force always obeys the inverse square law. Force is proportional to 1 divided by distance squared. In words, F1 over r squared. It is also a central force acting along the line joining the two masses, and a conservative force, meaning energy is conserved when it acts. Even though it is the weakest force, it has an infinite range. This is why it binds the solar system, keeps the Earth revolving around the Sun, and even holds galaxies together. The field particle associated with gravity is the hypothetical graviton. Next, let's go inside the nucleus with the weak nuclear force. It was discovered while studying beta decay. In this process, a neutron changes into a proton, releasing an electron and an antineutrino. This force is responsible for radioactive decay processes and the transformation of elementary particles. It acts on quarks and leptons and has an extremely short range of about 10 to the power minus 18 meters. Despite the name, weak, it is actually 10 to the power 26 times stronger than gravity. Its field particle is the neutrino, which interacts only weakly with matter. Without weak force, the nuclear reactions powering the Sun would not occur, and life as we know it would not exist. Now comes the electromagnetic force, the force of everyday life. It includes the electrostatic force between charges and the magnetic force between moving charges. This force can be attractive or repulsive. Like charges repel, unlike charges attract. It also obeys the inverse square law and is both central and conservative. Electromagnetic force operates over large distances and is about 10 to the power 36 times stronger than gravity. Its field particle is the photon, a massless particle of light. This force binds electrons to nuclei, atoms into molecules, and molecules into matter. From your refrigerator magnet to the lightning bolt in the sky, electromagnetism is at work. Finally, let's meet the strong nuclear force, the mightiest of them all. This force holds protons and neutrons together in the atomic nucleus. Imagine the repulsive push between positively charged protons inside a nucleus. Without strong force, atoms couldn't exist. Strong nuclear force is about 10 to the power 39 times stronger than gravity. But it is extremely short-ranged, acting only up to about 10 to the power minus 15 meters, roughly the size of a nucleus. Interestingly, it does not obey the inverse square law. At very small distances, it even becomes repulsive, preventing nucleons from collapsing into one point. The field particle of strong force is the pi meson or pion. It is this force that makes nuclei stable and gives rise to the vast diversity of elements in the universe. Now, let's compare the four forces side by side. The relative strengths are staggering: gravitational, weak, electromagnetic. Strong is equal to 110 to the power 26, 10 to the power 36, 10 to the power 39. Times gravitational is weakest but acts over infinite range, shaping cosmic structures. Times weak governs nuclear decay and processes inside stars. Times electromagnetic dominates at the atomic and molecular scale. Times strong force holds nucleons tightly in the nucleus. Together, these four fundamental forces explain every interaction in nature. All the countless forces we see in daily life are grouped into four fundamental forces of nature: gravitational, weak nuclear, electromagnetic, and strong nuclear. Each has distinct properties. Gravity binds planets, weak force drives nuclear decay, electromagnetic force binds atoms and molecules, and strong force binds nucleons in nuclei. These four forces, though very different, form the unified backbone of physics, governing everything from atoms to galaxies. I hope you now have a clearer picture of how the universe is held together by just four fundamental interactions. See you in the next session with another fascinating concept of physics.